and I'll be presenting today. So if we can start on the, first a little bit of housekeeping. As you can see on the slide, enable your speaker for hearing everything properly and mute your microphone. We've got a Q&A tab. With a large number of participants, we're going to need to wait questions until the end, or at least I'll need to wait to answer the questions until the end. But also, as indicated at the bottom, if you need to sign out early, you will still be able to get a printout of all of the slides and a link to the full recording of this webinar. So then I will ask Courtney to start recording, and we will begin. Again, today's presentation is IEC 61511. What's new in Edition 2? And again, my name is Eric Scharf. I'm one of the Exida partners in Asia Pacific region based in New Zealand. I was one of the original people at Exida, so I've been involved with this area for quite some number of years, and here is an array of information and background on what's been keeping me busy. As you can see, Exida is a global organization with main offices, regional offices, and sales offices spread throughout the world, and hopefully you can find your local support person and we can work with you. We offer an array of services from consulting, product certification, training, software tools, references, and individual personnel certification services and products. And here is a list of the various software and engineering tools that we currently have on offer. Again, Exida comes from a background of emphasizing knowledge and understanding, and as a result, some people would say we've written far too many textbooks. I sometimes feel in that category as well, but anyway, this is just a sampling of what we have out in publication at this point to help people guide themselves through the various functional safety standards and requirements. Today's session, as I said, is focusing on IEC 61511, second edition. And we're going to look at first how we've gotten to this point with functional safety standards. Then we'll talk a little bit about the things that are still the same as they have been for a number of years with 61511. Then we'll talk about the various changes both at the definition level and at the requirements level. Now, with the fact that 61511 second edition has not yet formally issued, I wanted to make sure that we have a solid agreed reference point. Everything in this presentation is based on the CDV, the Committee Draft for Voting editions of the standard from May of 2014, 691, 692, and 693, which are Parts 1, Parts 2, or Part 2 and Part 3 of the standard that were subsequently approved on August 2014. That is the most current stable version of the standard since it was approved overwhelmingly in August 2014. Any additional changes that are expected at this point should be relatively minor. Okay, so how have we gotten to this point? And again, we've decided actually only to go back 25 years. There are even further routes that go back well earlier than that, but starting with DIN 19250, the old AK rating for safety system controllers, programmable electronic systems. And then in the mid-90s, the development in the US of the ISA S84 standard, and the relatively soon following of the IEC 61508 first edition, which came out in 1998. The standards committees for 61511 were quite active in the early 2000s and came out with the formal release of IEC 61511, the Functional Safety Standard for the Process Industry, first edition, in 2003 and 2004. And then you can see over the past few years, both 61508 in 2010 and now 61511 in, I'll put it 2015/2016, because it's not entirely clear whether or not the 61511 will issue before the end of the year. From my experience with these things, it's always safe to bet on the later date, so I would think we're probably into early 2016 before we have the official release of 61511 second edition. Now, we have an array of current standards, and the 61508, as I said, the current 61508 is second edition from 2010. The current 61511 is still first edition from 2003, 2004, and in the US we have the ISA 84.00.01-2004, which is the functional equivalent of the 61511 international standard. We similarly have the 62061 machine sector standard, which came out in 2005, again at first edition. So I guess for the new 61508, I'd like to go back to Douglas Adams, the author of Hitchhiker's Guide to the Galaxy, where the guide to everything is written with a cover that has the words "Don't panic" in large friendly letters. And that's probably the first thing I'd like to say about the new 61511, and that is, don't panic. Yes, it is a revision to the existing 61511, but most things remain the same, and the changes that and the changes that are introduced as part of the second edition are A, generally good, and B, generally small to moderate in nature. So again, 61511, as it has since its initial release, will still target the end users, engineering contractors, and integrators in the process industries area. It will still cover the entire safety life cycle, from analysis phase through design, construction, installation, commissioning, validation, etc., into operations, maintenance, management of change, and eventually decommissioning. And again, just like all of the other functional safety standards, the big change from the past remains. It is a performance standard. It helps you set a clear target and demonstrate how you've achieved those targets. It does not tell you exactly what you need to do, and the old prescriptions of required configurations and so forth are not being reintroduced with 61511 part or second edition. Again, still focused on end user applications and still divided into the three main sections of the requirements in part 1, guidelines and advice in part 2, and then still target selection and risk analysis in part 3. It has the same relationship with 61508 as it always has had, with one sort of legal technicality. 61511 from 2004, whenever it references 61508, it references the first edition of 61508 because that's the only edition that existed in 2004. The second edition of 61508, which came out in 2010, was not referenced by the original 11. However, now that 61511 is going into its second edition, All of the references to 61508 will now be from the second edition of 61508 issued in 2010. But everything else remains the same. 61508 is generally focused on the design, construction, and fundamental programming of safety devices. And 61508 is still focused on the use and application of those devices in the process sector. So none of that has changed. The 61511 safety life cycle, it's still the same as before. We still have analysis phase, standard activities, estimating the risk, understanding the protection layers, and developing any requirements into a safety requirements specification. We then work into the same design phase, the same optional factory acceptance testing, installation, commissioning, and validation. And again, the same operation, maintenance, modification, or management of change and decommissioning, all of which remain supported by the verification activities, the safety life cycle structure and planning, and the management of functional safety and functional safety assessment requirements. It's still the same very powerful idea of setting up a risk control system. The risk controller, if you will, operates off of our tolerable risk set point, compares that to the risk we analyze in the analysis phases, and then generates a response of our safety requirements specification and other means of risk reduction to manage that risk back down to our target set point. We execute, design, build, validate, etc. that set of equipment. And then we feed into the operations phase where we again observe the behavior of that equipment and have now a real measure of actual risk that we compare back to our risk tolerance and again generate any required responses to that. This all remains the same. So, what is different? Well, as I said, at the finer levels, there are a number of tweaks to various definitions, and by and large, these are at least generally regarded amongst the committee and the community as improvements. And the first of these is providing a bit better clarification on common failures. So we've got both common cause failures, which result from a single event, where these failures are not consequences of each other. So they're not an event that causes another event. Those are not common cause failures. Then separate from that, we have common mode failures. Now these are failures at the same time of different pieces of equipment that fail for the same reason. So if I have a unit that fails at the same time for a different reason, that is still a common mode failure. But detailed difference between these two definitions, the most important element here is that each of these common failures is directly stated out. Whenever I have quotes in this presentation, they will refer to exact text from the standard. So we will see that from time to time in all of this. So, as I said, each of these common failure types reduces the effectiveness of system redundancy and fault tolerance. And we'll talk a little bit more about that later. Now, we have the completely new term, or at least new to the standard. Many of you have worked with this for quite some time, and that is the concept of a process safety time. The old 61511 really only considered the response time of the safety system. And the statements were very basic that said this response time had to be specified and that specification had to be met. However, the new 61511 defines the process safety time as the time period between which a failure occurs in the process or the basic process control system and the occurrence of the hazardous event if the safety function is not executed. Now, in Part 2 of the new 61511, the guidance is that the sum of the diagnostic test interval for the programmable or safety logic solver and the time to perform the specified action must be less than the process safety time. Now, this is actually somewhat different from the generally accepted rule of thumb that says the target response time for the safety system should be less than half the process safety time. So we have a little bit of a gap here between the statement in the standards and the accepted best practice on this. So that is something that we definitely need to pay attention to in our work here. So the difference here is something that we do want to pay attention to. All right. Another difference is that safe failures in the new 61511 are somewhat better defined for redundant systems. So whereas the old definition of a safe failure was often something along the lines of any failure which isn't dangerous in certain cases, especially with the old 61508. Now we have a clarification with fault-tolerant systems that say safe failures can either lead to operation where the safety function is available with a higher probability of success on demand. And the example would be where a 2 out of 3 configuration, one of the devices fails safe, which then effectively means that we have a 1 out of 2 configuration remaining in that situation. Or again, as we hopefully have always known, that a spurious operation where the safety action does trigger remains as a safe failure. So we do have a little bit of clarification around the voting structure here. This next definition is actually quite an improvement over the old 61511, because the old 61511 actually had a mismatch with both first and second edition of 61508, because the old 61511 did not define a high demand mode of operation. Now, the new 11 addresses this and clearly defines 3 modes of operation: a low demand, a high demand, and a continuous mode that is now consistent with the definitions of 61508. The split in all of these is that low demand mode is where the safety function is required to act less often than once a year, and the high demand and continuous mode are where the safety function is required to act more often than once a year. Unfortunately, there's a little bit of a problem in the math here, and the problem is that the proof testing frequency is no longer part of the definition, and unfortunately this can lead to some difficulties where the calculations might not give you the best answer if you're doing very frequent proof testing on a high demand mode of operation. We're just going to mention that here. This is a fair bit of involves a fair bit of detail in clarifying and specifically explaining, so we're going to need to leave that for another presentation, but at least I want to make sure that we have it noted and mentioned in this this current one. So again, we have 3 different modes of operation for our safety function in 61511 that is now in agreement with those same sets of definitions that exist in 61508. So for low demand, where we have less than once a year requirements for the safety function to act, We use our PFD average calculations. We get credit for proof testing. And we get credit for our diagnostics with lambda D, or dangerous detected failures, lambda DD, and as opposed to dangerous undetected failures, lambda DU. In high demand mode, more than once a year demands on the system, no credit for proof testing unless we have a non-zero hardware fault tolerance, and we take credit for automatic diagnostics. And then finally, at the continuous mode, where the requirements for the safety function are so constant that automatic diagnostics no longer have time to act. And as a result, we have both dangerous detected and dangerous undetected failures being equally harmful. And both of those go into the probability of failure per hour calculation for defining SIL in this. Okay. Next, well, again, not huge difference, but still worth noting. And this is that mitigation safety functions, or safety functions that leave you in a state that isn't 100% safe, that has some consequences associated with it. And the typical function to think of when you think of a mitigation safety function is a fire suppression system. And that is where it doesn't even trigger until there's already a fire. So even with the fire suppression system working perfectly, you have still had a fire. So that would be a classic mitigation safety function. Now, the new 61511 specifically leaves these mitigation functions out of one of the main figures, figure 4. However, in the definitions, it still acknowledges a mitigating safety function. And it still says that protection layers can be mitigating instead of achieving a perfectly safe state. So, interestingly enough, and I love this quote in part 3, or in clause 3, section 2, item 67, that says, some states are safer than others. Yes, that is clearly the case. But again, relative to the old 61511, I think it's important to note that safe state safety instrumented functions are clearly the preference in the new 61511. All right, another somewhat refinement rather than a major change is that systematic failures and random failures are much better defined in the new 61511. Now, there's been a lot of discussion about these. Exida has released a number of surveys and blogs and other presentations on this very issue. But I think as users of 61511 and practitioners of functional safety engineering, the real point of any of these definitions is so that we can use them intelligently to understand the behavior of our stuff better, and as a result of that understanding, identify and make intelligent improvements to either the design of our process or the design of the safety system that supports our process. So the random failures are defined by a predictable failure rate. Again, our value of lambda that we often use in calculations of PFD, PFH, etc. Realizing that these random failures will occur at unpredictable times. And they are not induced by a particular condition that would take away the randomness. So what the standard directs us to do then is to use the numbers. Use a quantitative approach, PFD average, PFH, those SIL verification calculations, as a way of managing our random failures associated with the safety system. Now, industry has recognized for decades that that's not the whole game. The second part of the game are the failures that remain, the systematic failures where we have a clear cause and effect type situation. That is, first off, the failure is reproducible. That is, I do X and Y happens. That is predictable, reproducible, and if I don't do X, Y doesn't happen. That is, they are removed, the failures removed when the cause is removed. And this is a completely different type of failure than the random ones. This one is very much managed in a qualitative way. This is where all of the quality assurance elements, the standard plan your activities, execute according to plan, cross-check and measure against plan, etc. All of that quality management stuff, all of that systematic failure management stuff. In the safety life cycle, all of the reviews, the functional safety assessments, etc., all of those techniques are what come into play to manage the systematic failures. And obviously, in order to achieve a given SIL, we need to ensure that both random failures, typically through the numbers in the PFD average calculations, etc., meet the requirements, and also the systematic failures must meet the requirements as well. And this is supported further by the emphasis of this systematic capability concept. It was present in the previous standard, but in a much more vague way. And now we have a much clearer definition. In fact, it even gets its own acronym. We have an SC level now, a systematic capability level. And this relates to the level of rigor used in the design of our equipment in accordance with 61508, or the level of rigor applied in our proven in use justification, that the devices we're using have appropriately low systematic failures or an appropriately high systematic capability. Now, again, systematic capability alone doesn't get you there. Obviously, you have to follow all of the guidelines and the other aspects of the 61511 safety life cycle. But again, it's clearly laid out that the systematic capability requirement of the individual devices must be met as part of achieving any particular SIL for an overall safety function. As I said, prior use is another way of demonstrating systematic capability, and the new 61511 has clarified that, but only slightly. And this is still a fundamental challenge in applying 61511 proven in use guidelines as a way of ensuring that systematic capability has been met. The concept is solid. It's, again, as it has always been, demonstrating that a device based on previous operating experience in similar operating environments achieves or is suitable, capable for use at a given SIL. And it is, again, a very powerful tool for managing systematic failures. Now, this is separate from the hardware fault tolerance that we'll talk about in a little bit, and it's separate from the PFD average and the random failure rates that we've already talked about. Now, even though the new 61511 lists a whole range of items which must be included in any proven in use or prior use justification, 61511 is still very short on the details. And if you really do want to get a firm understanding of the details, you actually need to go back to 61508 and look at the equivalent systematic failure management requirements in that standard to provide at least a reference point for how robust any proven in use justification should be in order to achieve the same result. Again, the details of this are outside the scope of our presentation, so I at least want to let you know that they're there and that you can follow up on those separately. Now, another change in 61511, and this is one of the more significant ones. The old 61511 made a relatively basic statement that said everybody needs to know what they're doing. The individuals must be competent to carry out the activities for which they are accountable. That's the old standard. Now, they were a little bit light on saying how that needed to be measured, how that needed to be tracked, even whether it needed to be tracked. And the new 61511 takes away that uncertainty. The new 61511 gives a very clear list of items that shall be addressed and documented when considering the competency of people involved in safety lifecycle activities. So now you have to show that everybody knows this list of stuff for the activities where they are responsible. It also requires a procedure to be in place to manage the competency of all of these individuals involved in the safety lifecycle. And it goes on to require periodic assessments. It doesn't say whether it's monthly, yearly, every 5 years, or whatever, but it still says that there must be documented competency and continuing assessment of competency to ensure that everybody knows what they're doing when they need to do it, and that you can show this and demonstrate this. So that is considerably more robust than the old 61511 in this area. So I think we'll all need to get our training records and our job description and requirements more finely tuned. We'll just say it that way in management language. Now, another significant change in the new 61511 is that we have a new specifically required functional safety assessment. Now, a functional safety assessment, you can look this up, it's not in the slides, is an independent judgment that you are achieving functional safety, that is, the risk is understood and managed to an acceptable level in a given situation. So the old 61511 absolutely required a functional safety assessment after the safety system was validated and installed and before the hazard was physically present. Now, that requirement still exists for 61511 new edition. However, the old edition only required that you consider it at the other points. You didn't actually have to do any other functional safety assessments. New 61511 changes that. New 61511 has the new requirement, and yes, it's buried deeply, section 5.2.6.1.10 in the operations and maintenance phase. So in order to comply with new 61511, you must carry out a functional safety assessment after a certain period of operations and maintenance. Now again, the standard is not going to tell you whether it's 1 month, 6 months, 12 months, or 5 years. But you do need to carry that out. And also, any modifications that come out from that functional safety assessment, each of those modifications will have to be reviewed themselves to determine any unintended consequences, or what the standard calls an impact analysis, before those changes are put into place. So there's also a couple of additional details on auditing and revision and so forth, with emphasis on things in the operations and maintenance phases. But by far the biggest change from old 11 is we are now required to carry out a functional safety assessment after a certain period of operations and maintenance. All right, so onward. There's a general tune-up of the design verification requirements. there's a slightly increased emphasis on testing and an expanded list of items to include in any particular verification test plan. So this is generally during the design phase of the safety life cycle, where we're putting things together and so forth. And this also cross-integrates with requirements of other standards, so that can be very helpful in a specific sense. So it, in 61511, calls out the requirement for other standards, such as burner management standards, for instance, that can be part of and should be addressed as part of any testing during the design phase. Another new thing with 61511, and this to a certain degree mirrors the new 61508 that came out several years ago, is that cybersecurity requirements are now a specific part of the standard. And as we see on the slide, 824 now says a security risk assessment shall be carried out to identify the security vulnerabilities of the safety system. Whenever you see the word shall, you have no choice if you want to comply with the standard. You must do this now. The standard also considers both intentional attacks, hackers, as well as unintended errors. And again, if any of you have played with a number of ICT elements, the unintended errors are actually more common than the intentional attacks, but fortunately are often not as maliciously dangerous. Now, the new 61511 includes a requirement as to how you're going to respond to these security threats, and that you have to be successful. That is, you have to achieve enough resilience against these risks, but it doesn't lay out any of the details. That is handled separately in the corresponding cybersecurity standards, and depending on whether you're in the US, Europe, or Asia Pacific, you'll have slightly different guidelines on those. But again, that's outside the scope of today at the detail level. The new 61511 simply makes the new requirement that we have to do this. There are a few additions to the safety requirements specification list. The new 61511 has 29 different requirements now for the safety requirements specification. And we've got some new I/O listing documentation requirements. We've got some trip point accuracy ranging elements associated with our sensors in those requirements as well. And we've got a little bit more meat behind the details for requirements on when we can and when we cannot bypass any elements of our safety instrumented function. Now, there is a bit of reorganization in the new 61511. The old Clause 12, the programming, the application programming section of the old standard, has shifted some of that information for the software safety requirements specification into the regular safety requirements specification and moved some of the planning aspects to 6. Now, these aren't that substantive, but it is organizationally different. We do need to pay attention to how this thing is organized so that we can keep track of stuff. And, oh, sorry, I mistake thinking different slide is next. So we'll cover that in more detail in a few more slides. Now, the next major change, and some would argue one of the most significant changes of the new 61511, safe failure fraction is dead. The old SFF, the lambda DU over total lambda, etc., all of those things that had your tables and chart requirements for how much redundancy did I need to build in 08 with type A, type B stuff, or with the Direct 11, is it 60%, 90%, 99%, etc. That's all gone. Now we have a single table of requirements, as is shown in this slide, of minimum hardware fault tolerance for sensors, logic solvers, final elements. And now it's classified by mode of operation and SIL only. There's a very nice one-to-one match here with 61508 second edition, a set of requirements that is known as Root 2H. So this hardware fault tolerance has been relaxed slightly and simplified. So we still have the same 3 requirements for SIL. We still need to make the numbers work for our failure probabilities. We still have hardware fault tolerance, but it's a lot more clear. And we still have the systematic capability, the systematic failure management requirements. But again, hardware fault tolerance is relaxed a bit. So in the past, where we had, again, for example, the old 61508 tables that 61511 sent us into immediately, we have this new table that, as you can see, at SIL 2 for low demand mode, we are okay with 0 fault tolerance, even with the old Type B device that would have limited us to SIL 1 for a low safe failure fraction. So again, this is a relaxation of the redundancy requirements that we used to have. So that is definitely something worth noting here. Another thing worth noting, and this ties in to a certain degree with the prior use elements, but more importantly with making sure we use good data in all SIL verification calculations. Good data is hard to find, and now we are more clearly forced to do just that. We need to find good data. In fact, the standard says failure rate data shall be credible, traceable, documented, and justified. So again, we need to have our ducks in a row here for making sure we use good values for the estimated failure rates of our devices in safety service. The new standard goes on to say that we should organize a relevant reliability data collection in accordance with these various other standards. So during operation and maintenance, we're going to need to collect additional reliability data. And finally, it also states that we shall assess the uncertainty of that data and shall take into account that uncertainty whenever we calculate our PFDs and PFHs. So again, we're going to need to pay a heck of a lot more attention to that failure rate data, and the old adage still rings true. If it looks too good to be true, it probably is too good to be true. So make sure, and again, the standard requires it, that you believe and can show why you believe the data that you're using in these cases. As I said, there was a bit of a reorganization of the new 11, specifically relating to the application software. Now, the old 61511 had a rather lengthy clause 12 that went into a fair bit of detail about application programming, V-model, software safety lifecycle, etc. Now, the new standard still has elements of the software safety lifecycle, but it structures it slightly differently. And we have this new diagram on our slide here, pulled straight from the standard, that helps us put this into the context of the overall project a little bit more clearly. So we have some additional clarity here in terms of how to look at the application software. Excuse me. Now, again, with limitations on time and detail, we're not going to be able to go into this in a lot of detail. And we're going to need to leave some of this stuff for another web seminar. But basically speaking, the new Clause 12 is divided or has divided application software considerations into 4 categories. You've got the general stuff, you've got the design of the software, you've got guidelines on the implementation of the software, and then guidelines on showing that the stuff works. So it's a little bit more concisely focused on a sequence of operations than it is with the old V-model diagram that appeared in the old 61511. Now, it's more of a change in organization than a change in requirement. So the overall application software requirements remain. But again, as I said, anything at the fine detail level, we're going to have to leave out of this webinar at this time, and we'll save that for a future date. As we then go into the final validation phase before we bring the safety function into service, and then the long operation and maintenance phase, there are some additional details on showing the software works. There is additional emphasis, as I said earlier, on bypass requirements for the safety functions. Making sure everybody knows what's going on and making sure you've got an emergency backup. Some kind of compensating measure to ensure that you don't kill anybody when you are maintaining these things and have them in bypass. As I said earlier, operation and maintenance now has its required functional safety assessment. So again, increased emphasis here. Also, and again, this is more of a general nature rather than putting out individual item by item here, time and time again in the new 11, you see references to this must be documented, that must be communicated, etc. There's general raising the bar here on our documentation. So we really need to make sure that we're writing a bit more stuff down and writing it down in a way that it's useful to our team in this. 61511 forces us to raise our game a little bit in that regard. Now, there's a lot of other stuff. Most of it's relatively straightforward. Actually, one nice thing that I noticed as I read through the new standard, the old 61511 left you with these pages of bullet points. New 61511 at least has the courtesy of numbering or lettering or labeling all of these things. So you no longer have to count the bullet points down on a page. You have letter A, letter J, letter K. Unfortunately, in some cases, you have double A and double B when the list stretches out beyond 26 items. So life isn't perfect, but again, at least it's more clearly labeled. As old 61511 warned you up, down, and sideways about SIL 4, new 61511 does the same, and actually even more so. Ask very serious questions before you try and specify a SIL 4. It's not good engineering practice in most situations, and the standards really clamp down on making sure you know what you're doing before you try and specify a SIL 4. There's also a few more robust supplier requirements, and again, this goes back to some of the aspects of competency and documentation. The 61508 functional safety management requirements are now called into play, rather than just saying your vendors have to have a quality management system. On the bright side, there's no real change to the factory acceptance test, installation, or commissioning. And then also, Part 2. In the old version of 61511, Part 2 was almost useless, I would argue. The new 61511, Part 2 actually has some value. It actually provides some element of reasonable explanation in some cases. So it's probably worth at least a skim through, depending on how well and how clear you feel Part 1 is. Part 3 of the new standard has a few more additional target selection examples and so forth, but again, it's informative and just there to help you and guide you through your analysis phase activities. All right, so where does that leave us? Well, as I said at the beginning, it should leave us without panic. New 61511 is not that much different from the old 11. It's clearer in a bunch of areas. It's more consistent with 61508 in a bunch of areas. It's got some additional emphasis on our competency, on verifying, making sure we do each step properly. A bit more emphasis on making sure we've got solid data to base or as a basis for our calculation. And again, it sort of raises the bar on our documentation and our use of documentation. But I would say the three biggest changes from old 61511 are, first, we now have to pay attention to cybersecurity. Second, we have a new required functional safety assessment. And third, we can back off a little bit on our hardware fault tolerance requirements. So again, overall, at least the word on the street is that the new 61511, and I would agree with this, is generally an improvement. But as with anything new, we need to pay attention to the differences, and any change will have its inherent level of challenge with it. So hopefully we can work our way through this and use the new 61511 to build our plants a little bit more safely, a little bit more easily. And I'd like to specifically emphasize that second one. The goal here is to achieve safety more easily and more confidently. And hopefully the new 61511 will enable us to do just that. So all right, that finishes the main section of our talk, and I'd like to open up the floor to any questions. Now, as I said at the outset, we've got a lot of participants in this webinar, and I will do my best to answer the primary questions that are coming up on the screen, but we will work as well as we can. Now, let me scroll up here. The window that it's giving me is somewhat small and challenging, but I will try and read through here. Let's see if I can make this a little bit bigger. Excuse me again. All right, so we've got will the systematic capability require device recertification? Now, the short answer is no. The certification of the device to 61508 is exactly what they're referring to when they talk about systematic capability. No, as long as that device has been designed and built to a 61508 capability of SIL 1, SIL 2, SIL 3, etc., that's fine. So no, recertification is not needed for the new 61511. Where can I buy a copy of this? Well, of 61508 and 61511. The IEC is usually the first port of call with this, and with the internet you can download it directly. Now, 61511 new edition is not on sale yet. It has not been released, and we do not expect it to be released for several months yet. So what I would suggest here is that just keep tabs on things. Every now and then Google up 61511 second edition release or something like that. Exida will publish, or will do our best to publish, the release of the standard on our website, and we could probably put a link to that. But again, just keep tabs on things, and the IEC itself is often a good place to buy these standards. Now, the question goes on to ask, oh, okay, nope, different question. Will the new requirement in competency leverage to a recertification process into the Exida CFSE program? There is a simple requirement in the new standard that competency must be documented. The new 61511 will change the CFSE and CFSP process applications exams. the new CFSE and CFSP will demonstrate competence in the new standard. But again, each company, each individual organization can choose to use any qualification as it sees fit as part of their 61511 documentation requirements. So the answer is sort of yes and no. Yes, the new 61511 requirements will be incorporated into the CFSE and CFSP exams when the standard is released. But existing certifications and existing competencies will be up to each company to determine what is sufficient in any particular case. To comply with Edition 2, will device manufacturers need to certify the devices against cybersecurity guidelines? Now, that is an unfortunately open question. It's not 100% clear from 11, except through its requirement that says you have to address the cybersecurity risks. Now, one would argue that good engineering practice would define addressing those risks as demonstrating compliance with other standards. However, it's not clear in the industry yet exactly what is needed for which application. And again, it is something that will be somewhat of a judgment call in this. So the short answer is yes, you will need to do something, but exactly what you do is going to be somewhat up to you in determining what indeed is sufficient to show that you have managed your cybersecurity risk. What happens to logic solvers that used to meet SIL 3 at hardware fault tolerance 0? That's a good one. Fortunately, most logic solvers that meet SIL 3 actually have internal hardware fault tolerance. So in a lot of cases, even though you may think it's a hardware fault tolerance 0, it actually has an internal hardware fault tolerance of 1 or 2 in accordance with 61508. So my suspicion is that when you really get down to it, nothing will change. However, if there is indeed a logic solver that does have 0 fault tolerance at SIL 3, there may be some challenges there. But again, that's really going to require looking at the details. Okay, next we've got, will Excellentia be modified to provide the uncertainty in the calculation per 11.9.4? Now, fortunately, that is something that is already addressed in the raw data and the SERH that comes with the Excellentia software. So that is more a question at the database level and the source of the data. And again, I would look in the fine print and the user's guide information in Excellentia to see the information that already exists about the uncertainty that is already built into the SERH data. Okay, do I have an expert opinion? I always worry about that question. Do I have an expert opinion on the qualitative value of safe failure fraction, even though it is dead in the new standard? How could a quantitative metric like SFF suddenly be without value in the context of the safety life cycle? Now, this gets very political, and I'm going to speak less here rather than more. That there were a number of arguments as to the value of safe failure fraction when it was initially brought into the standards, and those arguments have shifted one way, shifted another way, and I would say at this point the consensus has shifted more toward reducing the importance of safe failure fraction and hardware fault tolerance than was previously present. So I'm going to give my expert opinion by ducking that one to a certain degree. Okay, next one. I have seen several presentations in statistics indicating that 40% of the CIFs are due to a poor design life cycle. Do you know where these figures are coming from? Does Exida have any statistics on this? Now, unfortunately, this is very hard to get a handle on because we're talking about the difference between systematic and random failures. And systematic failures, by their very definition, are not numbers oriented. So we've got a real challenge in making this cut. And secondly, there's a wide range of arguments as to exactly what is systematic and what is random. Now, the new 11 defines this a heck of a lot better. So my hope is that in the future we'll be able to get these statistics, but I would argue that we do not have them at any level of accuracy at this point. So I can't comment on the 40% except to say that I would view this as very uncertain. When will the Excelentia tool be available updated? Well, I think this relates to a version 4 release of Excelentia that is in the midst of happening. I would refer people to the Exida website information on this, or asking specific questions to info@exida.com, since I'm not on the software development team. Did the latest 61508 eliminate safe failure fraction and hardware fault tolerance? No, it did not. 61508 second edition from 2010 still has hardware fault tolerance present in it. Does the standard refer to any other standards for cybersecurity? I didn't read it at that level of detail. And also I would wait until the final edition is released at the detail level, because everything is changing quickly. The cybersecurity standards are getting revised and released in parallel with the new 61511. So I would wait until the actual release of 61511 before I looked for a specific reference in that. Okay. When Exida SIL calculation software will be updated to incorporate these changes, as I said earlier, that's going to be, we have to first wait for the release of new 11, and then I would expect almost concurrently the Excelentia will have a capability to do that. The change is not that significant. By using generic reliability data like Exida Handbook to calculate the PFD average, how do we evaluate the systematic capability? Well, you need to be able to show either that that device has been built in accordance with 08, or that you have sufficient proven in use justification. So again, it's going to depend on what SIL you're looking at and how much supporting information you have. Now, I notice we're at 5 minutes past the hour. In deference to everybody who was not able to sign in, I'm going to continue asking or answering the questions on the recording for another 5 to 10 minutes yet. But if anyone wants to drop out, please feel free to do so and catch up on the recording. So, next question. Is it acceptable that manufacturer would declare the SC3 or SC4 instead of an authorized body? Well, that's a question of trust and independence. The standards allow it, but I would really ask some very hard questions about why a company would not bring in a third-party assessor in such a situation unless they've got something to hide or something that just isn't believable. So the standard allows you to simply take their word for it, but I would recommend a second opinion. Will ISA S84 adopt IEC 61511 second edition for USA use? My best answer to this is probably. Again, I don't, since I'm not in the U.S., I don't sit on the U.S. committees with the ISA, so I would defer that to someone who does, but from my perspective, the guess is highly probable. Are there clauses to allow practitioners to continue to use 1H and the HFT tables from 61508-2010? Again, I would wait until the final version of 11 new edition comes out to see that clearly. I wouldn't be able to make a statement at this point. Okay, my understanding was that old 61508 SIL4 was not achievable with programmable systems. Does new 61511 make this allowance? As I read new 61511, it heaps a few additional requirements on SIL4 and does not take any away. Okay. Will the release of 61511 edition 2 be delayed? And what is the new forecast date for publishing according to the IEC? Okay, nope, I'm reading this wrong. Okay, let me read that again. This is a comment rather than a question. The release of the second edition is slightly delayed, and the new forecast date for the publishing according to the work program is now March 2016. So thank you very much for that additional information. So again, the skeptics win out. March 2016 is the latest revised date, and as I said earlier, everything in this presentation references back to the last approved CDV. So again, everything's not set yet. Okay. Next question. If a device is not 61508 certified, are there different criteria on prior use? As I said, 61511 is pretty weak on specific criteria. It is still a judgment on the individual user's part as to what constitutes sufficient justification. And again, Exida has published a number of guidelines on this based on the idea that we're trying to achieve the same systematic capability confidence that the 61508 standard is doing. So a lot of it is cross-referenced against those requirements. But again, it is a very unclear set of requirements in the new 61511 on exactly what is or is not good enough for prior use systematic capability. There are some very clear limits on programmable elements and so forth, but in terms of how much data, how much confidence, that's still left a bit open. When are systems required to be recertified to the new standard after the release of the standard? Now, if you mean equipment certified to 61508, that will vary depending on the certifier. Exida certifications of equipment have an expiration date of 3 years. Unfortunately, some other companies have no expiration date. So yes, you might be compliant with the standard, but you also might be dead as a result. So I would raise some flags about that. The standard does not generally put dates in things. So that's where we're left in this situation. Okay. For people certified to the old standard, what is expected of them to get upgraded? Again, this will depend on what each individual company determines is sufficient documentation and sufficient competency in executing their safety lifecycle activities. Okay, we've got a comment that the 40% figure is often quoted in the HSE guideline note out of control. Now, that's a good comment. Excuse me. And that out of control documentation was from the 1990s. Now, you can be an optimist or a pessimist on this and say whether or not we've improved since the 1990s and reduced our systematic failure issues, excuse me, or not. And 20 years, 25 years is a fairly long time. So I appreciate the reference on those 40% numbers, but again, I could not comment further on the accuracy of them in terms of systematic versus random. Will the new 61511 standard penalize suppliers' devices that were previously approved via 61508 with units shipped as their main proven in use criteria? Again, that's at the detail level in proven in use, so that's going to be an open question. Okay, I see we're getting toward our final cutoff, so let me answer one more question, and then we'll sign off for the day. Will IEC 61511-2000 table and 2010 table for architecture constraints requirements still be available in the next Excellentia revision? That's an easy one. Yes. All right, so again, thank you all very much for your attention and your interest and your questions. And the webinar recording will be available on the Exida website in a couple of days. So thank you all very much for attending. And this is Eric Scharf signing off from today's seminar.